Continuing in our theme of right triangles, today we're going to look at two special types of right triangles and some of the properties of their sides. The first is an isosceles right triangle, which means that each of the legs is the same length. This is formed when you have a 45, 45, 90 degree triangle. And if you think about it, all triangles with 45, 45, 90 are similar to this little triangle here, which has two sides of 1. And then we're going to do a little investigating to understand the length of the hypotenuse. So if we use the Pythagorean theorem, we find out that the hypotenuse would be equal to the square root of 2. So whatever the side length is, the hypotenuse is the square root of 2 times whatever that is. And that is the special property of isosceles right triangles. Whatever S is, you can use that to figure out the hypotenuse length without having to do any other math besides multiplying it by the square root of 2. There's one other type of special right triangle, and that's the 30, 60, 90 degree triangle. And this is really just half of an equilateral triangle. So I took that equilateral triangle and just broke it in half in order to create two right triangles. Now, we know that an equilateral triangle, all of these lengths have to be the same. But since I'm only looking at really half of that in order to talk about the right triangle itself, and not the whole thing, not the whole equilateral triangle, I've decided to make this distance S. So that's only really half of one of the sides, which means that the hypotenuse of our right triangle is the normal length, or double the half length, aka 2 times the length of S. Now, the really complicated part comes with the third side of this triangle, but we can use the Pythagorean theorem again to figure out what is that side length going to be based off of the fact that this is S and this is 2S, or 2 times S. And when we plug everything into the Pythagorean theorem, do a little math, use some exponent rules, what you come up with is the pink length that I'm calling h for height is exactly equal to the side length S times the square root of 3. Now that we know the relationship of these three sides, whatever side we're given, we can find the others just by doing a little bit of math.